Okay, so this mini lecture is going to look at the concept of power. And what does power really mean when we talk about physics? Well, power describes the amount of work that can be done in a given amount of time. It's simply looking at how effective and efficient things can be. How much work can we accomplish in a certain amount of time? The less amount of time it takes for me to do a certain amount of work, the more power I have. So let's look at power from a mathematical perspective. Think of it conceptually, and then do a couple of practice, very simple, straightforward problems to examine what power means in physics. All right, well, straightforward, if we're thinking about work and time, power, if I increase the amount of work I have more power. If I decrease the amount of time I can do that work, I have more power. So imagine that an engine is moving a truck from a stoplight and trying to get down the road. All right, well, we know that the engine has to do a certain amount of work. And recall back from when we think about work, remember that work is force. It's the dot product of force and displacement. But for our purposes, force times the distance times the cosine of the angle that force is being acted on relative to that distance. All right, well, if I apply a certain amount of force in that engine, if I get to that next stop sign, so imagine that there's a truck and it's going from one stoplight to the next stoplight, and I have a really powerful engine, I can get that truck to that next stoplight really, really fast. Okay? So the more time it takes, the less effective it is. The more time it takes, the less power I have. If I have a really good, powerful engine, it's going to take me less time to accelerate that. So time is also important when it comes to power. So not only the work, so force, if I have a really forceful engine, we can imagine a very forceful engine. If I increase the amount of force that's exerted on that truck, I increase the work being done on that truck. That can get me, that feels more powerful. And if I decrease the amount of time, if I have a certain amount of work being done, but in less time, it's being done by a more powerful situation. So power, we look at this sort of like fat P. That is simply the work per time, okay? The work per time. Now, we know that work has the unit of joules, and of course, time is in the units of seconds. So power is joules per second, but we actually have another unit for joules per second. We call it a watt, and we use the capital W. Now be careful, there's a lot of W's going around here. We have W for the unit, we have W for work, we know W is also an object's weight. So as always, when we're dealing with certain units, we have to keep in mind that we have different representations and what we're actually referring to. So in the case of power, work is W, and so is its unit, the watt. All right. So in the next video, we'll do a little practice problem. But just the idea of power is the amount of work we can accomplish per time. If I increase the amount of work, more power. That's often done by kind of increasing that force. You can think of that as one way to increase the work. Or if I do that work over a shorter amount of time, then I am in a situation with more power. Awesome. All right. Good job.